LeetCode 2196, create binary tree from description. So we are given a description input. It's a integer of integer input, where we are given the parent and its child, and whether it's a left child or a right child. If it's a left child, then we are given value as 1. If it's a right child, then value is given as 2. So we have to construct the binary tree. So before we begin, right, in order to construct the binary tree, if we try to think how can we do so, right? So to create a binary tree, the very first thing we would need that which is the root node among all the nodes that are given. We are given 20, 10, 20, 17, 50, 20, 50, 80, 80, 19. Right? These many nodes are given, and we have to identify which is our root node. The first thing is to identify the root node. Right? And it's already given that each values in the tree is unique. So how we are going to identify the root? If we think from the description, we have parent and its child. So 20 is the parent, of which 15. So 15 cannot be our root element. 15 is a child, right? So a parent won't have a root node, won't have any. A root node won't have any parent, right? So 15 has a parent, 17 has a parent, 20 has a parent, 80 has a parent, even 19 has a parent. So 20 has a parent, 15 has a parent, 17 has a parent, 19 has a parent, 80 has a parent. Only 50 doesn't have any parent. So if we iterate on it and somehow we store all the children, let's say in a set, and then again we iterate on it, we will find our root node. So we can find our root node very easily. If we try to iterate on it, first save all the root nodes, because 15 is a root node, 17 is a, child node, 17, 20, 80 and 90. These are child nodes. Then again iterate on it and try to find if there is a, whoever is not there will be our root node. Right, so let's try to first do this. So I'll take a set where I'll store the children. Okay, new sub, and iterate on it. Let's say on the given description, and this is parent at 0th index, and child is at first index, and end is that is our second index. Alright, so first I have to store all the child nodes in the set. So what should we do? Let's name it as set. Set dot add child. Okay. So 10 will be added, 20 will be added, 20 will be added, 80 will be added, 19 will be added. Alright, now what we have to do, all these are in this set. So in order to find our root node, let's make a int root node value. Let's say it's initially 0. And if we again, and if we again iterate on it and check for each node, if it's present in the set, then it won't be our root node. If it's not, then that's our root node, right? Well, again, recopy everything, iterate on it, and that's it. Okay. If the set contains which one? Parent. If it doesn't contain that certain parent, right, that is our root node. the root node value will be parent, right? And that's how we'll find our root node. We can try to print it. System.out.print. Again, root node value, root node value, and we'll have it. Because let's try to say it, right? In the first loop, we stored 15, 17, 15, 17, 20, then 80 and 19, right? So all these are stored 20, 80, 15, not except 50. The next time we are iterating it, we are checking the parent. So 20, it's there, 20 is there, 50 is not there, so 50 is our root node. 50 is not there, 80 is there, right? So 50 is our root node. The moment we get anything, we'll just break it. No need to check any further. So we got our root node. But at the same time, right, now we have to construct our binary tree. So we have a root node, but how we are going to construct a binary tree? In order to construct a binary tree from the node, we need if the node has a left child or a right child, or if it doesn't have any child and it's a root node. So we have to establish from this input their corresponding left and right, if it has any or not. So how can we do it? I think it's pretty straightforward if we think of it. Let's say when we are in this one, we are iterating on the description, 20, 15, 1, right? So 20 is a node and 15 is its child node. That is on its left. So we can create 20, let's say we create a 20, maybe to store its left and right. We can use hash map. Yeah, hash map sounds good. So we'll use a hash map. Alright, integer followed by what it will store. It will store the nodes, right? And map, hash map. Okay. So the moment we encountered a new, let's say 20, so it shouldn't be present in the map, right? If map contains key parent, it doesn't contain it, right? If it doesn't contain, we'll create it. So what we'll do, map dot put parent, comma, new tree node with what value? It's parent. So we created the node 20 room. We created it. Now what we have to do? We have to assign 50 to its left, right? And if it assume it was already there, right? Because the next time it will always be there. So what we'll do? Else we'll get it whatever it already has, right? Some tree node current. Let's say we'll get map dot get parent. So if we already have, so we'll get our node. Now we have to assign its corresponding children to its corresponding value. So that part is, I think it's straightforward. If it's already there in the hash map, we'll take it from the map. If it's not, then we'll again have to create its child node also. Same thing like we did for the parent. If the parent is already there, then we add it to the map. If the parent is not there, if it's already there, then we got the map. Now what we have to do? We have added the map. Now it's time to establish the connections. So in order to establish the connection, we have the child node, right? So we have to again check if the child node is there or not. All right. So what we'll do? If again map dot contains key child, does it have? If it doesn't have, so we again have to put right map dot put, and it will be child new tray node child. Okay. And if it's already there, so we don't have to put it. This part is not needed actually. Only if it's not there, then we'll put it. And if it's already there, so it doesn't really matter because it's already there. We'll see how we are going to do that one. Now what we do? Now we try to get, right, map.get, not so, tree node parent, let's make it as P, parent node equals to map.get parent, and tree node child node equals to map.get child. All right. So if it's not there, we created it and we added it to the map. This part is pretty straightforward. Now what we are going to do, we have to attach it, right? And if the value is left is equals to 1, so this has to attach to this one. So how we are going to do? So parent node dot left is equals to child node, right? Else the opposite, parent node dot right is equals to what? The child node. And this should be done, right? If it's not there, we'll put it in the map. Put it in the map, and if it's there, we won't get executed. We'll just simply get the parent node and the child node, and then we'll attach it as per whatever information we are getting from the iteration, right? So this will create the binary tree, and we have identified our root node. So all that remains is to return map.get root node value. This will return the tree. Let's try to run it. What just happened? Okay. Cannot be converted. Oh, description, not descriptions. Ideally, it should run. Okay, again, the spelling is not correct. Or else. Yeah, done. Let's submit it. And it's done.